Okay, good morning class. So today we're looking at the Sansusi grade 11. Last year, 2020's end of the year, which is the November paper. Okay, in this video we'll probably cover a few questions, probably not the whole question, paper 1. Only a few questions of this paper. Okay. So in question, as you know, you're writing a 3-hour paper at the end of the year. The 3-hour paper constitutes or consists of, makes up 150 marks. Okay. This is also the first of the papers we're going through. It's important to do the homework before you get here so that you can identify the mistakes you have made in your attempt, and we can correct your understanding as well. Okay. So we'll go a bit fast through it, because at this point you have done it already. Okay, if you're watching the video, what's going to happen is you do parts of the question, you pause the video, and then you carry on. Okay. So let's look at the first question. We are told in question 1, solve for x. Now we can't divide by x here. Okay, because otherwise you're going to lose the solution. We never divide by a variable. So what we're going to do is we're going to bring this over the equal sign. So it becomes x cubed minus 8x squared equals 0. As you can see, x squared is a common factor. It's x minus 8 is equal to 0. So at this point, the 0 factor rule, you set each factor equal to 0. So x squared is equal to 0, so x is equal to 8, to 0. Or x minus 8 is equal to 0, x is then equal to 8. Okay. So look at the next question. In 1.2 people, this question here, leave your answer in third form, or it says normally to 2 decimal places. There's one question in question 1 that gives you irrational values. Okay? This is that question. If any of the other sums give you an irrational value, double check. Make sure you have made no mistake. Okay? Because it's only, or majority of the time, it's only one question that gives you surds or irrational values or roots. So this leads straight into the quadratic formula, which is x equal to minus b plus minus the square root of b squared, which is negative 9 squared minus 4a. Remember, I wrote this over the equal sign, which is 4x squared minus 9x minus 12 is equal to 0. Why did we bring it over? We needed to get it in the standard form, which was ax squared plus bx plus c. Not so? Okay, let's just do it on the top again. First take the 12 over, which is 4x squared minus 9x minus 12 is equal to 0. We want it in the form of ax squared plus bx plus c. Why do we want it in that form? So that we can use the quadratic formula, which is minus b plus minus the square root of b squared minus 4ac over 2a. Okay? When you do the substitution, as you can see, your a value is 4, your b value is negative 9, and your c value is negative 12. So it's minus minus 9 plus minus the square root of, I could have written positive 9, negative 9 squared minus 4, a is 4, c is negative 12. And this is all over 2 and a is 4. So x is equal to, put in the calculator. And for those of you who have the silver calculators that can punch that in the calculator and get the answer out, you are not going to be awarded the full marks here. Because there is 2 marks allocated for your correct substitution. Okay, so show the substitution. Sometimes 1 mark, sometimes 2 marks. Majority of the time, there's 2 marks allocated to it. Okay? So it's 9 plus the square root of negative 9 squared. I could have written 81, which is positive 9 squared, minus 4a, which is 4, and your c is negative 12, over 2 times 4. That gives you 9 plus the square root of 279, now 273 over 8, and the other one is going to be the negative 1. Okay, you all agree with that? Okay, any confusion? Look at the next question. We have 2x to the exponent negative 3 over 2 minus 54 equals 0. So what we do first is we take that over the equal sign. Becomes 2x minus 3 over 2 equals 54. So what do I do now? Divide by 2 both sides. Okay, which gives us x minus 3 over 2 equals 27. That's all. So how do I get rid of negative 3 over 2? I raise it to its reciprocal, which is negative 2 over 3. Now do this on the side as well. But remember 27 can be written as what? 3 cubed. Raised to the reciprocal. Okay, so that cancels of course. So x is equal to 3. 3 multiplied by negative 2 over 3 is negative 2. So 3 to the negative 2 can be written as 1 over 3 squared, which is 9. Okay, any confusion here? No? The next one? What we can do first is we can sort out the bracket there. Not so. So that's going to give you 16, 9 over 16 plus 1 is going to be 1 and 9 over 16, which is 25 over 16. Not so? So it's 25 over 16 equals 10. What's the square root of 25 over 16? Then they give you the square root of 25? 5 over 4. Not so? So what do I do now? How do I get 0,5 raised to the x on its own? Divide by 5 over 4 both sides. Not so? So 0,5 also can be written as what? Can be written as a half. So 10 divided by 5 over 4 is the same as 10 multiplied by 4 over 5. So it goes 2, so it can give you 8. Not so? Or you put it in the calculator. No problem with that. However, now we're going to try and make the bases the same for the exponents to be equal. So a half can be written as 2 to the negative 1 raised to the x, which is 2 to the negative x equals 8, 2 cubed. So what can I conclude? Therefore, negative x is equal to 3. Therefore, x is equal to negative 3. Any confusion there? No? Right, 1.1.5, your third question. Is the square root on its own? Is the square root isolated? Yes. So what do I do now? I square both sides. If the third was not on the one side, the equal sign, I'll get it on its own first. Okay? So what's the square root of 5 minus x all squared? 5 minus x equals. First term square is going to give you x squared. That times 2. So they give you plus 2x plus 1. People, if you have written x squared plus 1, you do not apply the binomial square rule. You write it out twice, which is x plus 1 times x plus 1, and you apply the distributive law. Okay, because we see too many times that learners make that mistake over and over again. Okay? So don't risk the mark. Keep yourself brave. Just do the long way. So it's x squared plus 2x plus 1 minus 5 plus x. I'm bringing everything to the one side of the equal sign y because that's a quadratic equation. At like terms, it's x squared plus 3x minus 4 equals 0. This is what now? Trinomial. Okay? Trinomial. So one of two things I can do, people. It's either I can apply the trinomial factorization rules or quadratic formula. Now if you are messing up your signs, or sometimes you're getting the roots wrong and other times you're okay, in that case, people, you apply your quadratic formula all the time. Okay? Apply the quadratic formula. So that is one thing I'm sure you guys can do. Okay? Besides other things. You can apply the quadratic formula safely. So that, if you factorize it, it's going to give you 4 and 1, plus and minus. So x plus 4 is equal to 0, so x is equal to minus 4. Or x minus 1 is equal to 0, so x is equal to 1. Now this sum here, we need to test if it's correct. Okay? So what we do is we put negative 4 wherever you see a x. So it's going to be the root of 5 minus minus 4, which is 9, and 4. 5 plus 4 is 9, which is 3. Can you see that? I put negative 4 on the side. Negative 4 plus 1 is negative 3. Is 3 equal to negative 3? No. So that is not the solution. Put a line through. Okay? It's a common asked question in matric as well. No? Matric paper 1, the grade 12 paper 1. So questions asked all the time. Okay? More often. If I put 1 in here, it's going to be the square root of 5 minus 1, which is the square root of 4, which is 2. If I put 1 in here, what's 1 plus 1? 2. So that one works. Okay, you don't have to tick it. You just not pull a line through. Okay? You guys understand? Calvin? You okay? Why's your head down? Don't have to look at the sums. You don't know. What do you say? Nothing personal. You must mark your work. You do the work. Okay, good. You got all the sums there. Now you must take note. People, 1.2. You must get a simultaneous equation. Okay, and here's your simultaneous equation. This is an exponential equation, so you must make the bases the same for the exponents to be equal. So 4 can be written as what? 2 squared raised to the x is equal to 2y minus 1. Multiply. So it's 2 to the 2x is equal to 2 to the y minus 1. So therefore, what can we conclude? 2x equals y minus 1. So you get over the equal sign. So y is equal to 2x plus 1. That's now equation 1. Right, you guys got it? So what do we do on the other end? Here we have 25 can be written as what? 5 to the 2. So it's going to be 5 to the 2y. Therefore, x is equal to 2y. When bases are the same, exponents are equal. You all agree I can substitute equation 1 now into equation 2. Okay? So wherever I see a y, I put the 2x minus 1. Can you see that, people? So what you're going to have now? X is equal to 2 times 2x plus 1. So what do I do now? Multiplying, get rid of the brackets. So it's 4x plus 2 equals x. So negative 3x is equal to 2. X is equal to negative 2 over 3. You all agree with that? Is correct? So what do I do now? I'm going to solve for y. So you put it in the first equation. Or the equation where we have y as the subject of the formula. So I can then say therefore y is equal to 2 times negative 2 over 3 plus 1. Which is negative 4 over 3. It's going to be 3 is negative 1 over 3. Is that correct? Any confusion, people? Any questions? Now you all understand, eh? What I'm going to do is I'm going to take this off. Because as you can see, I'm running out of space. One point 3.1. I want to know where x plus 2 into 1 minus x greater than or equal to 0. What does that mean? It's your inequality question. You must get your inequality question in question 1. So is this parabola a minimum or a maximum parabola? Is this parabola minimum or maximum? Remember, what is my critical values here? My 0 values. Negative 2 and 1. Not so. So is this graph going to do that in the first instance? Or is the graph going to do that? Is the graph going to have a minimum value? Or is the graph going to have a maximum value? Sorry? Minimum. Why? You see, when would this be minimum? If the a value is greater than 0. If your a is positive, from the equation y is equal to ax squared plus bx plus c. If a is positive, the graph will have a minimum. Is a positive or negative? No. How do I get the coefficient of the number in front of x squared? It will be x times negative x, which is negative x squared. So this graph is actually going to have a maximum value. Can you see that? So this graph is going to have a maximum. At negative 2 and 1. So we told that f of x, or x plus 2 times 1 minus x, must be greater than or equal to 0. Greater than or equal to 0 means what? It must be positive. So when is something positive? It's above the line. Can you see that? And that's what I showed. Is this a continuous or a break-in solution? It's a continuous solution. So your solution for your inequality is going to be together. Not so. So what do we say? X must be more than negative 2, but less than 1. As you can see, as an equal sign there, equal, equal. That's one way of doing it. Otherwise, what I could have said was, swap that around. What's going to happen if I swap that around? Negative comes out. Not so? What do I do now? Divide by negative. So it's going to become x plus 2. X minus 1 is less than or equal. Whenever you're multiplying or dividing by a negative number, your inequality changes, swaps around. So my critical values, never say your x is equal to, no? Critical value negative 2 and 1. Here's negative 2 and here's 1. Y is equal to 0. What does this tell us? X must be, or the y value must be less than 0, not so. And what does less than 0 mean? Below the line, where it is negative. Above is positive. So what do we notice? Continuous or break-in solution? Continuous. From minus 2 to 1. Equal because of the equal sign in the sign. You guys understand? Any confusion here? Right, let's look at the next question. The next question we are told, write down the number of integer values of x which satisfy the given inequality. Integer values. What are integers? What are integers? Integers are positive and negative whole numbers here. Not so. So you must write down the number, the amount, in other words, the amount of integers that satisfy this equation. Would I consider a negative 2 as one of the values? Yes, why? There's an equal sign. If there was no equal sign there, I would have not considered the negative 2. Does it make sense? Why? Because it was excluding. Because there's an equal sign there, it is including. Does it make sense? Negative 1? Yes. 0? Yes. 1? 2? No. So how many values satisfy this equation? Therefore, 4 values. Okay. Any confusion? Understand? Right, let's look at the next one. They say that if m is the largest possible integer for m to the 200 has to be less than 5 to the 300, determine the value of m. So where do we start? We say, okay, that 200 there, and here's a 300. So I could have taken the 100, the root on either side. Not so. You take the 100th root on either side. Remember, there's nothing to do with the negative here, so no inequality swaps now. Okay. So in other words, here we'll have now m squared has to be less than 5 cubed, which is 125. Not so. Again, if m is the largest possible integer for m to the 200 is less than 5 to the 300, determine the value of m. So this here, people, this is, what are these? Squares, perfect squares. Which is the perfect square closest to 125? 5 squared is what? 25. 10 squared is what? 100. So I must still carry on. 11 squared. What's 11 squared? 121. So close. What's 12 squared? 144. Can you see that? So if m was 11 squared, does that fit the inequality? Is 121 less than 125? Yes. So that is still true. Let's test for 12. 12 squared. Is 12 squared less than 125? Remember, this is 144. Can this be the case? No. So therefore, the largest possible value for m is going to be 11. 10, you could be yes. 9 could be 81. 8 could be 64. But it's not the largest value for m. Does it make sense? So therefore m has to be 11. Let's look at the next question. Question 2. Question 2, we are told simplify each of the following without the use of a calculator. So, as we know, this calculation can be done on the calculator and you'll get the exact answer, but you won't be awarded the full mark for typing it into the calculator. Okay? You must substantiate or accompany your calculation with the supporting calculation, okay? Or the appropriate calculation. Right, so 72. The largest perfect square. What are perfect squares? 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, 7 squared, 8 squared, and so on and so on. The largest perfect square that goes into 72 is what? Should be 36. Not so? The 36 times what is 72? No. The largest perfect square that goes into 50. 25 times 2. Over. For 8? 4 times 2. So what's the square root of 36? 6 root 2. Square root of 25? 5 root 2. Over 2 root 2. What is 6 root 2 minus 5 root 2? Root 2. Over 2 root 2. So what's going to happen now? Those cancelled. Leave you with. Okay. Any confusion here? 2.2. So the first thing is we're going to break this up so that we can factorize. Okay, that's your exponential expression. So you break that up and factorize. I know some of you can do it without breaking it up. No problem, you can apply that as long as you understand what you're doing. And I'm going to break it up. So it's going to be 3 to the x times 3 squared minus 3 to the x times 3 to the 1 over 3 to the x times 3 to the negative 3. So now what do? We're going to look for a common factor. The common factor, of course, is going to be 3 to the x into 3 squared minus 3 to the 1 over 3 to the x times 3 to the negative 3. What can happen now? 3 to the x cancels. So 3 squared is 9 minus 3 over 1 over 27. 9 minus 3 is 6. Divided by, which becomes multiplied by 27 over 1, which is 167. 267. 162. Okay. Any questions yet? Question 3. The roots, okay, the roots of the x values, so the solutions, okay, to a quadratic equation are given by x is equal to 4 plus minus the square root of 6 minus 3p over 5. If p is equal to 1, determine the nature of the roots. So the nature of the roots is dependent on what? On the discriminant, the delta. In this case, my delta is 6 minus 3p. If delta is less than 0, what do we know about the roots? It's non-real. If delta is equal to 0, what do we know then? The roots are real, rational, and equal. If delta is greater than 0, and it's a perfect square, what do we know about the roots then? It's real, rational, because it's a perfect square, the square root can be taken, and unequal. If it's a non-perfect square, not a perfect square, it will be real, irrational, and unequal. So the only time the roots are equal, if delta is equal to 0. Okay. So coming back to the question. The question says if p is equal to negative 1. So then delta is equal to 6 times, 6 minus 3 times negative 1, which is 9. Is delta greater than 0? Yes. Is delta a perfect square? Yes. Why? Because the square root of 9 is 3. So therefore, roots are real, rational, and unequal. Okay? Any confusion here? Let's look at 3.2. For which value or values of p will the roots be non-real? When are roots non-real again? Roots will be non-real if delta was less than 0. Again, what is delta? 6 minus 3p. So you say 6 minus 3p must be less than 0. Not so? We put here 4 non-real roots. Delta is less than 0. Where did I get a delta? From the introduction to the sum. So we take a 6 over So it becomes negative 3p must be less than minus 6. What do I do now? Divide by negative 3 both sides. So therefore p is more than. Why is it more than? Dividing by a negative 1. Whenever you divide and multiply by the negative, your inequality swaps around, changes. Let's look at question 4. Given the quadratic sequence, what is exclusive to quadratic sequences? What will you only find in quadratic sequence? There is a second difference, not a first and second. There is a first common difference. Okay. Determine the general formula for the given. Determine the formula for the general term for the sequence in the 4-bar. Okay, so how do we move from? Okay, this is right here, negative 9, negative 10, negative 7, 0. Right, how do we move from negative 9 to negative 10? Minus 1. From negative 10 to negative 7. Plus 3. Then? Plus 7. How do I move from negative 1 to negative 3? Plus 4. How do we get that? 3 minus minus 1. 7 minus 3 is 4. Or we must add 4 to 3 to get 7. You want to agree with that? What do we write on the side? 2a. 3a plus b. A plus b plus c. Bottom up. Not so? So what do I write here on the side? 2a is equal to 4. So a is equal to? Not so? 3a, 3 times 2 plus b is equal to negative 1. So it's going to be b is equal to negative 1 minus 6. Negative 7. So we've got a plus b plus c is equal to 9. So c is equal to 9 minus 2 is 7 plus 7 is 14. It's negative 9. Okay, no problem. So it's going to give you an answer of 0. Is that correct? Negative 4. So that's going to give us 2 minus 7, negative 5. Yes, negative 4. Absolutely. Sorry about that. So therefore Tn is equal to 2n squared minus 7 minus 1. And the sum is worth 4 marks. And there's sums that follows that depends on the formula. The formula is correct. So it will be worth our while to test if it's correct. So what I do is I substitute, if I see an n, I substitute 3. If the answer is negative 7, it's correct. The answer is other than negative 7, I've made a mistake somewhere. I would never choose number 1 or n to be 1 because I used the first term in calculating the C value. So irrespective if your answer is right or wrong, the first one will give you the right answer. Does it make sense? So let's test. So we go 2 times n is negative is 3, sorry. Third term minus 7 times 3 minus 4. Must be squared this. Thank you. You negative 7. So that means to say it is correct. Let's look at the next question. The next question is 4.1.2. Determine T19. So wherever I see n, I put the 19. So it's 2 times 19 squared. Minus 7 times 19 minus 4. So it's 2 times 19 squared minus 7 times 19. gives you 585. Is that correct? Okay, 585. Then in 4.1.3, the question says determine the smallest value for n for which the nth term of the sequence is greater than 4,841. Determine the smallest value. Determine the smallest value for n for which the nth term, which is 10, of the sequence is greater than 4,841. You see that again, an inequality question. So what is Tn? Tn is a general term. So it's 2n squared minus 7n minus 4 must be greater than 4,841. Okay? So I bring that over the equal sign. It becomes 2n squared minus 7n minus 4,841 in the negative minus 4. So it will be 4,845. So, one of two ways I can do here. I can work out the critical values either by using the quadratic formula, or I'm going to use the cubic factor, the trinomial factorization. The trinomial factorization will take a very long time. So the factors of 4,845 is fairly large. Okay? As you can see here, 4,845. It's quite a few factors. Okay? It's quite a few. And it's large numbers as well. So the quadratic formula is going to be the best bet. You guys understand? Okay, or if you've got this calculator, we can use this function. So it's going to factorize to negative 7, negative 4,845. That gives me your critical value of 51 and negative 95 over 2. Okay. So if you plot this on your graph, negative 95 over 2 and 51 is there. Firstly, could n be negative? No, because what does n represent? A term number. And your term position can't be negative. Not so. Can it be a fraction? No, it has to be an element of natural numbers. So in other words, I'm only looking at the positive part of the graph, from 0 onwards, or 1 onwards. Okay? So, read the question again. Determine the smallest value for n. So remember, this is greater than 0, so that's where I shade, and that's where I say. Remember, I'm not going to consider anything on the side. Not so? So read the question again. Determine the smallest value for n, for which the nth term of the sequence is greater than 4,841. At the 51st term, at this value here, it is actually equal to 4,841. So what is the smallest value for n? Therefore, what's the value for n going to be? The smallest value greater than 51. 52 years. So therefore T52 is the first term that is greater than 4,841. What if they ask you, determine the value of the first term that is greater than 4,841? I would have gone through the same steps. Then I would have substituted 52 into the general term, and I would get the value of the 52nd term of the sequence. Okay? Yes?
So, can you please explain again from the critical values?
You see, the question says, for which values of n will the first term of the sequence be greater than 4,841? So currently, if you look at the sequence is negative 9, negative 1, negative 10, 7, negative 7, 0, and the numbers carries on. Okay? Now there will come a point where you get 4,841. and 41 in the sequence. So that is the 51st term. How do I know that? By doing the calculation now, right? So they want to know which is the first term greater than this. The very next term, which is T52, is going to be the term greater than. Okay? So if I bring it back to this inequality here, we know these are the critical values of the zero values. I am omitting anything less than 1. Why? Because your n value must be positive. You can't get somebody standing at the negative 5th position. Alright? And again, it can't be a fraction. So, it must be greater than 1. So, that's the point I have to consider. So, which is the smallest value that is greater than 51? It's 52. That is why it's going to be the 52nd term. Why am I not considering 51 and a half? Because n must be an element of natural numbers. You understand? Sorry? No, it's a pleasure. Okay. People, let's go to the next one. In 4.2.1, write down the 5th term of the sequence. How do I move from one term to the next? How do I move from one term to the next in the sequence? How do I move from there to there? You divide by 2. Divide by 2. Or we can say we are multiplying it by r. So this is term 1, term 2, term 3, term 4. They want to know what's the value of term 5. So it's going to be 1 over 8 times a half, which is 1 over 60. Then it says, determine the formula for the general term in the form Tn. Now what type of pattern is this? What type of pattern is this? It's a geometric pattern. So how do we know that? We've got the common ratio. Geometric patterns has a common ratio. Arithmetic or linear patterns has a common difference, the first difference. Quadratic pattern has a second common difference. Okay? So the general term of geometric pattern is Tn is equal to A or n minus 1. What is your A value? What's your A value? The A value is normally the first term of the sequence. What's the first term of the sequence? 1. What's your R value? Half n minus 1. Okay, so you can write it like that, or you can write it as a half n minus 1, or you could have written 2 minus 1, 2 to the n minus 1. Any of those would be acceptable. Okay? Let's look at the next question. (4.2.3) Use your formula above to determine the number of terms in the sequence. Do we have the last term of the sequence? Yes. The last term of the sequence is 1 over 4096. So the nth term is 1 over 4096. But what is Tn? Tn, so half n minus 1. Or I will write that, whatever, it doesn't matter. Equals 1 over. Now, in exponential equation, we're going to try and make the basis the same for the exponents to be equal. Not so? So we go 4/96. Whoops. 4/96 can be written as 2 to the 12. Not so? This here is going to be 1 to the 12 is 1, 2 to the 12 is 4/96. Therefore, n minus 1 is equal to 12. Therefore, n is equal to 30. And this question here before you guys leave, Explain why. One over 8,193 is not a term in the sequence. If you're going to solve for n here, there's going to be n minus 1 equals 1 over 8193. You see, the basis can't be written the same. So we can't equate the exponents here. Then we're going to go into what we call logs. Okay, I think we have done that already. So n minus 1, if we apply logs both sides, it's going to be log of raised to the n minus 1 equals log 1 over 8193. I didn't need the bracket there. So n minus 1 is equal to log 1 over 8193 over log of. So you put that in the calculator. It's going to be log 1 over 8193 over log of minus 1 or plus 1. You see, this is going to be 14,000. How many zeros are here? 31761. But we know that n must be an element of natural numbers. Is that a natural number? No. Therefore, it is not a number. It cannot be a term in the sequence. Okay? Otherwise, if you had entered that right on top there, they would have given you the 1 mark. Okay, I'm just showing you why it's not the case. Right, so for tomorrow's lesson, we'll carry on by question 4.3. People enjoy the rest of your day. Good morning, class.